My presentation is on anaerobic respiration. Anaerobic explained. There are two types of cellular respiration, aerobic and anaerobic. Aerobic respiration uses glucose C6H12O6 and oxygen O2 to make energy stored as ATP, water H2O, and carbon dioxide CO2. Sometimes plants and animals can't get enough oxygen to use aerobic respiration, so they use anaerobic respiration. Anaerobic respiration doesn't need oxygen. Aerobic literally means without oxygen. There are two different anaerobic respiration reactions, the animal reaction and the plant reaction. The animal reaction uses glycolysis to break down glucose into lactic acid, C3H6O3, and energy stored as ATP. The plant reaction converts glucose into pyruvate, C3H4O3, through glycolysis. The pyruvate is then converted into ethanol, C2H5OH, and carbon dioxide through fermentation. Overall, aerobic respiration is superior to anaerobic respiration because anaerobic produces less energy, lactic acid, and ethanol. Ethanol is a little poisonous to plants, and lactic acid causes muscle cramps in animals. Chemical equation. The animal chemical equation is glucose yields 2 lactic acid and energy. The plant equation is glucose and enzymes yield 2 ethanol and 2 carbon dioxide and energy. The reactants for the animals is glucose, for the plants is glucose and enzymes. The products for the animals, lactic acid and energy. For the plants, ethanol, carbon dioxide, and energy. Chemical and physical properties. Glucose is highly flammable. Its density is 1.56 grams per centimeter cubed. It's sweet and it has no odor. Lactic acid is slightly acidic and it has a density of 1.06 grams per milliliter. Its melting point is 18 degrees C. Ethanol is flammable. It has a similar odor to whiskey. It has a density of 0.789 grams per centimeter cubed, which is less dense than water. Carbon dioxide is colorless and odorless and more dense than air. These are my particle diagrams. You can see for the animal side, we have glucose is equal to 2 lactic acid. And then we have, for the plant side, glucose is equal to 2 ethanol and 2 carbon dioxide. And this is my stoichiometry. For the animal, because I did 2, we have how many grams of glucose we need to make 300 grams of lactic acid. And I got 300 grams of glucose. And then for the plants, I got how many grams of glucose we need to make 100 grams of carbon dioxide. And I said 204.68 grams of glucose. Other information, it's an exothermic reaction, meaning it releases more heat or more energy than it needs to break the bonds. And it's also a decomposition reaction, meaning it breaks down into simpler compounds. It has covalent bonds, and covalent bonds are bonds between two atoms with similar electronegativity that are trying to take away electrons from the other atom. Since they're pulling on the electrons with similar force, the electrons are shared. The way you can tell that is a chemical reaction is there is a change in temperature because it is an exothermic reaction. Is anaerobic respiration useful? Well, anaerobic respiration is very useful. It is vital when little oxygen is present. Many foods are created using fermentation, such as bread, yogurt, alcohol, and others. It also creates biofuels. And that's my presentation.